Let's have a look at the poll questions that you didn't get to do the other day because I had to cancel class. Are you ready? The first question is about a screening test for breast cancer. I realized a few years ago that I spoke about these screening tests assuming that you all knew what they were because, well, my demographic knows all about them. And I finally came to realize that you might not, so let me go over them. A mammogram is a screening test for breast cancer. Now, results of a mammogram, if something shows up, that doesn't necessarily mean there's cancer. 80% of the time, it's perfectly benign. A PSA stands for prostate-specific antigen, and this is a screening test. It's a blood test for prostate cancer. Normally, cells in the prostate, the healthy organized cells, only allow a small amount of this antigen to get into the bloodstream. But with prostate cancer, cells are disorganized and more of this antigen can leak out into the bloodstream. So the PSA levels may be higher. The thing is, it's not known whether those high levels of PSA are related to cancer or to an infection. Lead time bias refers to the time between cancer formation and the presentation of symptoms. That is true. This is the example of lead time bias that I talked about in the video. Beth gets on the train in Boston, Nancy gets on the train in New York, and the train crashes in Washington. Both women die. It may look like Beth was a longer-term survivor, but that's only because she got on earlier than Nancy. And how does that translate into cancer screening? Well, let's look at these two examples. On top, we have cancer when cancer starts. In both cases, the person on top and the bottom, cancer is starting at the same time. Without screening, the person on top is diagnosed at age 67 and dies by age 70. So their 5-year survival rate is 0. With screening, this person was diagnosed at age 60. They still died at 70, but the 5-year survival rate is now 100%. Both people died at the same time, but one appears to have had a longer survival time because they were diagnosed earlier. What do you think about that? This information may really have an effect for some people on whether or not they want to have screening tests. Cancer is one disease affecting many parts of the body. True or false? The answer to this one is false. Cancer is not a single disease. There are hundreds of different types of cancers. All tissues and organs can be affected. A tumor isn't always cancerous. This is true. I talked about how there are different signals that regulate cancer growth. We have internal regulation, where you have suppressor genes that normally curb cell growth, and that may fail with the BRCA gene. If it's mutated, then those cancer cells are allowed to grow. You may have external regulation that fails, and transformed cells are no longer listening to their neighbors that are telling them, don't come into my space. And so they also continue to grow. In this case, the regulation that prevents cells from growing fails, and malignant or cancerous tumors grow. So a tumor that is malignant, malignancy refers to cancer. Do you remember when we talked about mutations? I talked about how most mutations are harmless. That's the same with tumors. Benign means harmless. All right, so just because you hear the word tumor, please don't assume that it's a cancer. Apoptosis refers to programmed cell death. This is true. Normally, cell growth is carefully regulated by those internal and external signals that we talked about in the previous slide. Apoptosis stands for programmed cell death. For example, as I said in the video, red blood cells are programmed to die after around 3 months. The cells inside your mouth or your intestines usually last about 3 days, and they are replaced by new cells. With cancer, this program stops working and the cells continue to divide and divide and divide. We have angiogenesis, a cancer cell that moves to another part of the body can grow because of angiogenesis. And this video showed what happens is when that cell goes to a different part of the body, it may start sending out signals that attract new blood vessels. And when new blood vessels reach those cells, they can get nutrients that they need to grow and they can get rid of waste products. So angiogenesis enables metastasis, and metastasis stands for the transport and regrowth of cells from a primary tumor to other parts of the body. Eating a healthy diet and exercising regularly will prevent cancer. The answer to this is false. With few exceptions, studies of human populations have not yet shown definitively that any dietary component causes or protects against cancer. If you see this diet, this supplement, these behaviors will prevent cancer, that's a red flag. What these should be saying is may help reduce risk. Carcinogenesis may be reversed at any stage of development. This is also false. According to the theory of carcinogenesis, when a normal cell becomes an abnormal cell, or the period of initiation occurs and the DNA creates mutations, that stage may be able to be repaired by antioxidants, phyto or plant chemicals, or normal mechanisms in the body. However, once the abnormal cell experiences promotion, then progresses to a tumor, please remember this is one hypothesis of carcinogenesis, of how cancer forms. Dysplastic cell changes are more likely to become cancerous than hyperplastic cells. This is true. These are the different stages that cells may go through as they become cancerous. A normal cell may experience hyperplasia, which means that it increases in number. It still has distinct borders, it still has one nucleus, and it may reverse itself. But if hyperplasia progresses to dysplasia, when we look at the dysplastic cells, we see that they're now looking abnormal, that they are merging, that the nuclei are misformed or malformed, and dysplasia may then progress to cancer. And these were the folks that were supposed to present their current events. I hope you signed up for another day. All right, see you in class.